Welcome to the lecture pertaining to the feeding devices under the edges of chemical process utilities. Now, before we start the discussion about the various feeding devices in continuation with the previous one, let us have a brief outline about that what we studied in the previous lecture. You see that in the previous lecture we discussed about the influences of material properties on the conveying system, air conveying system. We discussed about the various feeding devices, this inclusive of rotary valves. We had a discussion about the air leakage. We discussed about the entrainment devices, different rotor types and feed rates. Now, in this particular lecture, we are going to discuss about the screw feeders under the edges of simple screw feeders. We will discuss about the variable pitch screw feeders. We will discuss about the Venturi feeders, gate locked valves. We will discuss about the suction nozzles, and at last we will discuss the fluidizing membranes. Now, let us talk about the screw feeders. Now, screw feeders they have the same application as rotary valves with respect to positive and negative pressure conveying system. We have already discussed the rotary valves. Now, these are positive displacement devices. The feed rate can be achieved by varying the speed. However, the air leakage in such kind of screw feeder is a problem when feeding to positive conveying system. When we talk about the different classes of screw feeders, so there are two type of screw feeders and both have very different capabilities with regard to pipeline feeding. One is the simple screw feeder and second one is having the variable pitch device. Now, let us talk about the simple screw feeder. In this type of feeders, the rotation of screw moves the continuous plug material into the pipeline. The advantage is the approximate linear relationship in between screw speed and material flow rate. Therefore, the discharge limit can be controlled within the closed limits. Now, it is rarely used for feeding positive conveying systems. Air leakage is the major problem, so they are limited to vacuum type of a system, because as you know that in vacuum system the chances of air leakage are negligible. It can be used in conveying line up to 35 pounds force per square inch pressure. Now, here you can see the pictorial diagram of a simple screw type of a feeder. Here this is the screw and which is moving with the help of this drive shaft, and the material is subjected to here, and you see that it is moving in this direction. Air is supplied to this direction. The check valve usually controls the flow movement, and here you see that air and the material in question is coming out. Now, variable pitch screw feeders, so the main feature are the screw decreases in pitch along its length, and that is the material to be conveyed is compressed to form the tight seal in the barrel. Now, if it has application in cement industry as well as in the fly ash, and where it is being used to convey the fly ash in the power stations. So, when we talk about the variable pitch screw feeder, it required very high power input for the feeder. The device is useful for the material that can compressed and air retention properties such as cement and fly ash. It is used for high pressure closed loop conveying of fine and potentially combustible materials. Now here you see that the commercially variable screw feeder. Now here the theme is similar. Here you are having the drive shaft. This is the rotating screw. You are feeding the material from this through this hopper, and here we are having the weighted NRV, that is non-return valve. Air is subjected with the help of a jets, and air and material is coming out from this port. There are various Venturi feeders. The problem of air leakage with the feeding positive pressure conveying system, this can be minimized by using Venturi feeders. Now it consists of reduce in pipeline cross section prior to the region where the material is fed from supply hopper, followed by divergent section. The consequence of this reduction in the flow area is an increase in entraining air velocity and corresponding decrease in pressure. In Venturi, the pressure at the throat, it should be same or just a little lower than that in the supply hopper, that is atmospheric pressure. The Venturi is capable of feeding material into the conveying system with the operating pressure drops to 5 pounds force per square inch. Now here you see this is the commercial type of Venturi feeder. Air is subjected through this nozzle. We are having the throat, and that is the integral part of Venturi. You are feeding the material with this flow control valve, and the air and material is coming out from this port. For flow control of the feed, a calibrated orifice plate or gate slide valve, this provides a suitable degree of control for the material to be fed. Now gate lock valves, they consists of two doors or gates that are alternatively open and closed to permit the passage of the material from the supply hopper into the conveying line. These may be a motor driven, cam or air cylinder operated, or may work under gravity. The air which passes the lower gate from the conveying pipeline is vented so that it does not interfere with the material about to flow through the upper gate in positive pressure system. It will provide the controlled feed rate. That is why it is very much an intermittent type of a feeder. The gate lock feeder typically operates at between 10 to 15 cycles per minute. Now, in order to maximize the material flow rate through a conveying pipeline, the air supply pressure, this needs to remain reasonably constant. They are used to feed large granular materials. Now, while we feeding such kind of a large granular materials, care must be exercised to prevent the large particles from getting trapped in the gates and causing them to buckle or deflect, because the large particle may block the opening of these gates. Now here you see this is the commercial type of gate valve feeder. Here you are feeding the material. These are the flow control devices, and this is the hopper equipped with a seat, and here you see that this is the gate. Now here you are having another lower hopper equipped with the seat and a gate, and the material with the air, it is coming out through this way, and you are feeding the air supply in counter current fashion, and all the vented air is coming out. Now this is the cross section where you see that this is the material flow channels. This is the vented air, here the air supply, and you are getting the material in the similar fashion. Now, suction nozzles. Now, it is essential with the suction nozzle to avoid filling the inlet tube solidly with material and to maintain an adequate flow of air through the conveying line at all times. Now, to avoid any kind of blockage, that is very common phenomena. So, in order to avoid any kind of blocking in inlet pipe, sufficient air must be available at the material feed point. Now, even if the suction nozzle is buried deep into the bulk solid material, the vacuum offloading system must be able to operate continuously with the nozzle buried in the material at all times in order to maximize the material flow rate. Sufficient air must also be available for conveying the material through the pipeline once it is drawn into the inlet pipe. In order to obtain the maximum output through a vacuum line, it is necessary to maintain as uniform a feed line to within the line as possible. Now, here you see this application of a vacuum nozzle to hopper offloading. Now, this is the supply hopper and vacuum nozzle. So, this goes like this to the delivery port, and here you are having a flexible hose through which you can change the direction. Now, to satisfy the requirements of two air inlets are required, one at the material pickup point and another at the point downstream. Now, here this is the material inlet point. Now, this entire suction nozzle for the vacuum pickup, this is the sleeve or housing, and the primary air is subjected at this port and the secondary air is subjected to this port, and this is the pipeline. Trickle valves. Now, trickle valves, they are suitable for negative pressure conveying system as there is no pressure drop against the feed. The flow rate control is main problem with this class of feeders. A slight change in the particle size, shape and moisture content, this will affect the balance of setting for material, therefore change in the flow rate. So, obviously the flow rate will change accordingly if it affects the balance of the setting of the material. Now, there is a need of a short length of pipeline prior to the material feed point. There will be a slight pressure gradient in the direction of material feed which encourage the flow of material into the pipeline. Now, this is a widely used device in industries because of cost advantage over another alternative method of feeding negative conveying system. As far as vacuum conveying applications are in question, so for vacuum conveying application, the pipeline used to convey material is generally extended a few meters ahead of the hopper. This will done to make sure that the air inlet is in a safe place for health and safety requirement. In the addition of flow restriction in the section of pipeline by using simple orifice plate effect lowering the pressure at material feed point and helping to promote the flow. Now, here you see the typical trickle valve arrangement for feeding negative pressure pneumatic conveying system. You see here we are supplying the air, the material in, and this is the slide gate valve with an isolation, and all these things is in control. Now, here additionally you are having one adjustable air inlet and entire air plus material is coming out to this port. There are certain blow tanks. It is employed in pneumatic conveying systems because of capability of using high pressure air. Now, as high pressure is required to convey over long distance in dilute phase, or to convey at high mass flow rates over short distances through small bore pipelines. Now, it is neither restricted to dense phase conveying nor to a high pressure use. Materials can also be conveyed in dilute phase also if it is not possible in dense phase. Blow tank they can serve as both hopper and feeder. So, the problem of air leakage do not raise, or you cannot experience the problem of air leakage in the blow tank. Usually you can say that there is a small pressure drop across blow tank in order to discharge material into the pipeline. Now, there will also be a need to vent the blow tank when it is filled with the material. So, you need to continuously discharge, and that depends on the capacity and the requirement of these blow tank and the size of the blow tank and the Now, there are different type of blow tanks, especially we are discussing there are two type of blow tank. First is the top discharge and second one is the bottom discharge. And for each type there is an alternative configurations and which are always possible. The different blow tanks which are similar but due to different arrangements, they have different conveying capabilities and control characteristics. Let us talk about the top discharge blow tanks. It has a discharge valve which isolate it from the conveying line. It has also the vent line and the valve, that is why it can be depressurized independently of the conveying line. The discharge is arranged through offtake pipe positioned above the fluidizing membrane. Material is discharged vertically up and discharge pipe exists in the blow tank through the top of the vessel, therefore termed as top discharged blow tank. It is not possible to discharge it completely, as with the conical membrane very little material will remain in the tank. The cross contamination does not occur due to this type of tank, those are dedicated for a single material. Now, here you see the top discharge blow tank. This is the supply hopper as usual. You are having this blow tank vent line. Now, this is the discharge pipe and here you see that this is the fluidizing membrane. So, air is supplying through this port and that air is a fluidized air. Sometimes you need to supplementary or conveying air to be subjected over here. Now, this is the blow tank and here you find the conveying line. Now, when we talk about the arrangements of top discharge blow tank, one category is that with fluidizing membrane. The discharge arrangement you see that here, the discharge arrangement is ideal with the fluidized base by membrane for air supply provided. Now, this air supply for controlling the membrane material flow rate is vary the air flow rate, but this influences both the conveying line inlet air velocity and conveying line pressure drop. So, it is not at all recommended. Now, another is that with conical offtake pipe, there is only air supply. The situation here is more worse as the air has to permeate through the material to get to the point discharge. For materials have wide particle size distribution, re-aerated rapidly and the system does not work. Another category is with aerated base. It has one air supply into the tank which is used to fluidize the material, and a supplementary air supply is also available to dilute the material discharge to require solid loading ratio for conveying through the pipeline. The air is entered a plenum chamber at the base of the tank and enters the blow tank in area where material is discharged. Now there is 1 millimeter gap in between the bottom of the conical wall of blow tank and the flat base. The air passes here to both aerate the material and to pressurize the blow tank. Let us talk about the bottom discharge blow tanks. Now here there is no membrane. The material is uninterruptedly passage to the gravity fed into the pipeline. Therefore, the content can completely be discharged. Now here you see that this is the typical figure of bottom discharge blow tank. As usual, we are having the material hopper which is subjected to the inlet valve. Now this is our blow tank with the discharge valve, and this is the vent and a balancing line. Air is subjected to here and the material is gradually coming down, and you can get this air and material. So for some materials, adding an air supply to a point close to discharge point to fluidize or aerated the material in this particular area. Now when we talk about the arrangements of a bottom discharge blow tank with air inlet to top only. Now single air supply on the top, although the bottom discharge blow tank has advantages of gravity discharge. Now in this case it discharges the material with a little control. The application of such type of configuration is strictly limited unless air is introduced into the pipeline downstream of blow tank via trace line or boosters. Another class is that with air to top pipeline, there are 2 air supply which are necessary for full control, but for many materials air needs to be introduced near the discharge point to promote the flow. Another category, that is with the 2 air supplies at the base. Here you see the air enters into the plenum chamber and fluidizes to aerate the material in the blow tank close to discharge point through the narrow annular slot. This type of arrangement works very well. Now if there is a pressure in the blow tank is greater than that of air supply, then it is possible that the fine materials will flow back into the plenum chamber and has block and cease to operate effectively. Now let us talk about the fluidizing membranes. It consists of porous plastic, ceramic or filter cloth sandwiched between perforated metal plates. A perforated plate is required for provide support against the pressure of fluidizing air from beneath. For powdered material, the offtake pipe needs to be spaced about 2 inch above the base or membrane. If it is too close, it may adversely affect the discharge rate. Now here you see this is the porous membrane which is at the stipulated height with the offtake pipe, and you can feed the air inlet from the plenum chamber over here. This showing the straight and discharge pipe. So at last in this particular segment we discussed about the feed lines, feed system for the conveying system, and for your convenience we have enlisted 4 different references. You can have a look of all those references if required. Thank you very much.